In this video, I'm going to introduce the octet rule, which is very important for understanding why elements gain a net charge. I lifted this frame directly from our video on Lewis structures, and it shows 6 elements with their valence electrons arranged as an electron dot diagram. Now, if I were to ask you which one of these elements looks fat and happy, which one would you pick? I hope you would pick neon, because neon is the one that is fat and happy, and neon is the only one on this page that is fat and happy. Why is neon fat and happy? Because neon has a perfect complement of valence electrons. Recall that neon's electron configuration is helium plus 2s2, 2p6. When you see that 2s2, that is an s orbital that is full. And when you see 2p6, that is a p orbital that is full. So at the highest energy level, neon has full orbitals, and that's what makes it happy. And that is what all of these other elements also would like to attain. Well, all except hydrogen. Hydrogen does not want to attain a full p orbital, so we'll just erase him from the picture right now. But all of these elements would like to attain the feeling of the full orbital. Now, what would lithium have to do in order to attain that feeling of fullness? Well, we see one lonely valence electron right there, and we remind ourselves that lithium's electron configuration is helium 2s1. So if lithium were to lose that one electron, then it would also lose this part of its electron configuration, and it would be exactly like helium. Now, helium doesn't have 8, but helium is full, and so it's happy. Notice what happened, though. Now we lost an electron. So lithium, which is element number 3, atomic number 3, now has 3 protons and only 2 electrons. So lithium in this state has acquired a charge. It has a net charge of plus. And it turns out that most metals want to lose their electrons so that they can acquire a plus charge. Now let's look at chlorine. Chlorine has 7 valence electrons. Chlorine only needs 1 more valence electron to get that full and happy feeling. And so that is what chlorine generally does in its chemical reactions. It acquires 1 more electron, and now it has the same configuration as neon. But let's see what happened to its net charge. Because chlorine started out with 17 protons, and now in this configuration it has 18 electrons. And so in this configuration it has acquired a net charge of -1. And in general, that is what nonmetals want to do. Nonmetals want to attract 1 more electron to themselves so that they'll have that full and happy feeling, but along with it, they acquire a net charge. So the octet rule, as stated in our textbook, says, most atoms strive to attain 8 valence electrons. I suppose I should have mentioned that the oct in octet actually is a Latin root that means 8. There are, of course, two notable exceptions to the octet rule, and these would be the only exceptions. They would be hydrogen and helium. If you remember the electron configuration for helium, it's 1s2. Helium is the second element. It has 2 protons, and when it has no net charge, it'll have 2 electrons. And so the only orbital in its energy level is full, and that equals just as fat and happy as all those other noble gases that get to have 8 valence electrons. So hydrogen, of course, with its 1 valence electron, strives to get 2 valence electrons so that it will be like helium. But hydrogen is a bit of a maverick, and we are going to see when we study acid-base chemistry that it will lose its 1 electron and become a proton.